Topic 12 tackles the geometry of straight lines, and in this first section we are going to focus on perpendicular, intersecting and parallel lines. Here's a picture that illustrates an example of parallel lines in practice. These are power lines, as you can see, and parallel lines, which we usually indicate with an arrow symbol. So this means that these two lines are parallel, meaning that if you take the distance at a point, let's name this point A, and compare it with the distance at another place, let's call it point P, then this distance is exactly the same for P as for A between the parallel lines, if we assume that they are meeting at perpendicular angles. The other example that in the past already I've indicated is like the train railway or train track. It has to be apart the same distance as the wheels of the train, in fact, otherwise the train will go off the rails. So even if a turn is made, the distance, even including that turn, should be exactly the same width as the wheels of the train. Next, let's focus on the concept of angles on a straight line. So if we, for example, take this straight line, let me color it kind of in. So it's this straight line moving from, let's make it point A to point B. Then we can determine the angles on the same side. They will have to add up to 180 degrees, as a straight line is 180 degrees. So the angles that are on that straight line will also have to add up to 180 degrees. But the important part is they need to be on the same side of the straight line. So for straight line AB, for example, angle 2 and angle 1, they are both to the right of that straight line. So those two angles together, angle 1 plus angle 2, will equal 180 degrees. Reason will be in brackets angles on a straight line. Can even use the abbreviation angles on a STR line for straight line. Perfectly acceptable. So similarly, if we look at the angles on a different side of the straight line, let's just change the pen color to assist us in this. So if we go to the left hand side, or the bottom side, suppose it's another way, of AB, then angle 3 and angle 4, those two angles together will equal to 180 degrees. And it will obviously be exactly the same reasoning. Let's take another scenario. We can take line, let's call it CD. So line CD, and then we can say, well, let's look at the angles to the right of that one. So that would be this angle 1 and angle 4. So we can say they are on the same side of that line. So 1 plus 4, those angles equals 180 degrees. And then obviously 3 and 2 is on the opposite side of line DC, so those two together will give 180 degrees. So I believe you are getting the idea. So let's look at another definition, namely that of the intersection. Intersection is the point at which two or more straight lines cross. So where the red dot is, that is the intersection of this line and that line. Let's give them names again. So line AB and line CD. Where line AB crosses line CD, at that point we refer to it as the intersection. Next, let's focus on vertical opposite angles. So vertical opposite angles are non-adjacent. Adjacent means yes, next to each other. So non-adjacent means it's angles that are not immediately next to each other. They are in fact opposite angles. So formed by two or more intersecting straight lines. So now here we have 1, 2 straight lines intersecting. So since there's an intersection, we know that we can look for vertical opposite angles. We are looking at opposite ones, so 2 and 4 are opposite each other. They stare at each other. Therefore, they are not next to each other. They are non-adjacent. Okay, so an example of an adjacent angle would be 1 and 4. They would be right next to each other. Or 3 and 2 are right next to each other. They would be adjacent. 3 and 4 would be adjacent as they are right next to each other. So another vertical opposite angle will be 3 and 1. They are opposite each other. They are staring at each other. They are not next to each other, so they are not adjacent. They are non-adjacent. So 3 and 1 will be equal. So angle 1 equals angle 3. The reason vertically, and this is acceptable abbreviation, vertical op for opposite angles. Okay, so vertical opposite angles are equal. Similarly, angle 2 equals 4. Same reason, vertical opposite angles. So now let me illustrate the easy way to determine this. Let's color this line blue. Let's take another color pen. Let's make this one red. So basically you're looking at the color, the different colors, blue and red. You take blue and red, you basically connect them since they are different colors lines. So you connect that angle and then you look at the opposite one that have the different colors red and blue and they are equal. So here also you can see red and blue, blue and red, opposite, therefore vertical opposite angles and equal. So maybe color can help you a little bit. So next, let's move on to the concept of perpendicular lines. Previously, in the previous chapter, we already kind of indicated, or it might even be this one when I prepared you for the assignment, that if two lines meet each other at a 90-degree angle, we refer to it as a perpendicular lines. The angle is obviously a perpendicular angle, but the lines are perpendicular lines. So it's two straight lines that form a right angle, which we know is a 90-degree angle. Small square is the symbol for it where they meet. Angles around a point. So if we have a point and we have angles all around that point, we can actually draw a circle. So we also refer to this as a revolution. And we know a circle has 360 degrees. So all the angles around will add up to 360 degrees. So 85 degrees plus 110 degrees plus angle B equals 360 degrees. Reason, you can either say angles around a point or revolution. Any one will be acceptable, and then we can go and calculate B, but I'm just focusing on illustrating the concept here. So let's move on to exercise 12.1. Firstly, write down the vertical opposite angles in these diagrams. Okay, so let's take two lines that intersect each other. So I'm going to draw this one red. Let's take another one. And let's draw that one blue. Okay, so now let's see what we can find for these two. So we said one strategy is just take the different colors, the red and the blue, find on the opposite also the red and the blue. So therefore we can say 1 plus 2 must equal to 5 plus 4. Okay, so they are vertically opposite. Or you could even say 1 and 2. They didn't ask you to write down necessarily that they are equal. They just wanted you to indicate which pairs are vertically opposite. But it would also be fine to say equal. It's actually even more correct, because that's how we will use it in general in future. But now we just test the very basics. Okay, so then we could say, okay, let's try something else. Let me get the eraser. Let's remove the blue. And let's now try something different. Okay, so, no, not red. Let's take yellow. And let's take another line. Let's use this one here. Okay, so now red and yellow, opposite, yellow and red, they are staring at each other, so therefore 1 and 4. So angle 1 plus 4 should be equal to, or rather angle 1 and 4, or 1 equals 4. Okay, so we know 1 equals 4. We could also look at 3 and 2, yellow, red, yellow, red. So therefore 3 plus 2 and 5 plus 6 those angles are staring across each other. Okay, so let's see, what combination did we not try yet? Well, I think I'll leave it for you to on your own try the other ones, and then let's add that to your task that you will do. Okay, so number C. I'm in fact going to ask you to try number C on your own. So quickly try number C on your own, and then compare it with my solution. Okay, so we have the two lines that are crossing. There are only two that are in fact crossing. So we can take a blue and a red, look at another blue and red that kind of is opposite each other. So therefore we can say 2 and 5, or 2 equals 5 even. That's one possibility. Let's look at another one. So we can say blue and red, and then kind of opposite we have red and blue. So let's see what we can get from this. So we have 4 and 3, and one, eh? Okay, so this one is a bit more tough, eh? Red and blue. Some of you might have been tempted to take it right across and say it's 1 and 2, but it's in fact only 1. Those are the only possibilities I believe I can see here. So let's move on. So in these diagrams, this is now number 2, AB, oh, and by the way, this is the symbol for perpendicular. So AB, upside down T, symbol for perpendicular. So AB perpendicular to CD. So it means AB and CD meets at 90-degree angles. So use this information to determine the size of the unknown angle in each case. So therefore, this one is straightforward. X is in fact 90 degrees. Reason being that AB perpendicular to CD. Number 3. Determine the size of the angles marked A to D in these diagrams. Remember to give reasons for every statement you make. So what I see is a straight line, and I see angles on the same side of that straight line, namely on top of it. So on top of that straight line, we see all the angles, 1, 2, 3 of them. So these three angles together must therefore add up to 180 degrees. So we can say 30 degrees plus angle B plus 45 degrees. 45 degrees equals 180 degrees. Reason being angles on a straight line. So now we can solve. So we know we want the letter of the alphabet on the one side, we want the numbers on the other side. So on the left we have B. On the right hand side, on the correct side of the river, we already have 180 degrees. So nothing to do for the Mr. 180 degrees. It is where it should be. But 30 and 45, which is 75 degrees on the wrong side, it needs to cross the river. So the plus 75, the sign changes when it swims through the river, it becomes negative 75 degrees. So therefore, angle B equals 180 minus 75, which is 105 degrees. Number C. I want you to attempt on your own. See if you can determine what is the value of C. So I have red and blue, blue and red. They are opposite each other, not adjacent. So therefore, angle C is in fact equal to angle 25 degrees. Reason, vertically opposite angles. Opposite angles. As simple as that. I'm sure most of you got it right. So, your task number 1A of exercise 12.1, number 2A, number 3A, number 3D. And that small Jana portion of the one that I said you should finish. Remember those vertical opposite angles where we had like 3 or 4 lines crossing each other? I did most of it, but I said you must try the others. It's a bit of a harder one. So let's see. But I have full confidence that you will be able to cope with it.